Now, there is a biological implication of osmosis, and it's an actually a crucial implication for the survival of any patient who is subjected to some intravenous solution in case the patient is coming out of surgery and cannot feed themselves, or they have some situation which requires some kind of intravenous delivery of some drugs, for example. Well, inside the blood in the veins where an intravenous injection is made, there are red blood cells, and those red blood cells are basically bathing in the liquid called plasma, which is a solution of water and other components. Now, the inside of the red blood cell as well as the plasma both have the same osmolarity. As a result, there is no flow of water or plasma from the plasma inside the red blood cells or from whatever is inside the red blood cell, that particular substance moving out in order to balance out the osmolarity. However, if doctors were to make an intravenous delivery of some drugs or nutrients inside the patient directly, then care must be exercised that the solution used does not interfere with the balance of osmolarity that's there in the cells. For example, what happens if a red blood cell was immersed in a solution that's more dilute than the red blood cell itself? Or what happens if a red blood cell was immersed in a solution which is more concentrated? So here is what happens. What you see on the bottom is the actual shape of the red blood cell. It looks like a disc. However, if the red blood cell was put in a solution which was more concentrated than plasma, then the solvent from inside the cytoplasm of the cell would move out just like osmosis demands. And because it moves out, the red blood cell will wrinkle and will look like the way we see it here. But what happens if the red blood cell was placed in a solution which was more dilute than the contents of the red blood cell itself? Then the solvent from the outside would move inside and it would basically expand the red blood cell, even causing it to rupture and die. These three situations have a name. For the middle portion, where the outside as well as the inside osmolarity is the same of the red blood cell, we say that the solution and the red blood cell are isotonic to each other. Now, in the case where we have the inside that is more concentrated than the outside water starts to move in, we say that we have placed the red blood cell in a hypotonic solution. Hypotonic. And finally, if the contents of the red blood cell had to move out because the outside was more concentrated than the inside, then we say that the solution outside is hypertonic. Now, how do we exercise care for intravenous delivery at hospitals and nursing centers? Well, for intravenous delivery, usually what's prescribed is something that's called a normal saline solution or a 5.5% dextrose solution, which you see here being being administered to a patient. So these solutions are known to be isotonic to the blood, and so when they are delivered, that would not cause the red blood cells to wrinkle or to rupture through being blown up.